Hi students, welcome to Maths Point of View. Today we are going to understand the concept of simple application of refraction of light, that is nothing but part C of refraction of light. Okay, here the terms are very simple, easy to understand, and we are going to solve each and every theory question which is there in the textbook as well as all the numericals. All those two videos will be available in the description box. Now without wasting any time, we'll start with our concept. As I told you, this is a very simple topic. What we are going to learn in this topic, listen. Whenever there is an object inside a denser medium, you know what is denser medium and rarer medium. This is what we learned in part A of refraction. Those are the complete basics of refraction of light. Now listen, whenever an object is in denser medium and when it is viewed from this one rarer medium, this is the denser medium. Assume this is aquarium. Okay, aquarium. This is a denser medium compared to air, right? So whenever an object is in denser medium and whenever it is seen from the rarer medium, the complete height of the aquarium or any object, okay, the complete height of the this one aquarium seems to be less, appears to be less. This is because of refraction. This is what we are going to learn. Okay, the thickness of the aquarium, or if it is below, this object is below the glass slab, okay, below the glass slab, the thickness of the glass slab appears to be less when it is viewed from the rarer medium. That is because of refraction of light. That is what we are going to learn in this concept. Okay, listen, first we'll understand the concept here, then few examples and what are the factors, all those things we are going to learn. Now listen, assume this is the object which is kept inside a aquarium, now listen, whenever there are some this one rays coming up, see, this is one possibility. A ray can go in straight direction without deviation, and one more ray can go like this, correct? Whenever it hits the surface, because of the refraction, it goes away. See, from denser medium to rarer medium, speed increases, correct? Speed increases, that is why it is going away from the normal, and this is what we are going to see. But I told you this object appears to be little raised, correct? Raised up. How we are going to get that? If you extend this ray, wherever, if you have to use the scale, okay, whenever you are drawing the ray diagram, whenever if you extend this one, wherever you are going to see this intersection here, there we are going to see the object. Now the concept is very simple. Whenever an object is viewed from a rarer medium and the object is in the denser medium, it appears to be little raised up. This is where we are going to see the object. Now what are the terms we are going to learn here? See, the complete thickness, okay, the complete thickness is considered as real depth. What is that? Real depth, okay, actual depth or real depth. Now if you see from this point, it is observed that object is somewhere here. So from the surface of the medium till where we can see the object, that is nothing but apparent depth. Now we'll learn the relation between real depth and apparent depth. How to find the real depth or how to find the apparent depth, all those things. So that derivation is there in your textbook, but for a syllabus it is not there. If you learn the formula, that is enough. Now see, the formula goes like this: refractive index is equal to real depth by apparent depth. Mu is nothing but the refractive index of the medium. If you are talking about aquarium, that is nothing but we are talking about water, so that will be refractive index of water. If you are talking about glass slab, then refractive index will be refractive index of glass slab. That's it. Then real depth, apparent depth. Most of the time they will ask us to find the apparent depth only. The same formula you can use it like this: A is equal to R by mu. To find refractive index, this formula, assume this is the primary formula, whatever we find, okay, we are going to find, we'll change it according to that. Next, some examples how it appears to be raised up, how much it appears to be raised up. If that depends upon, completely depends upon the refractive index. The refractive index of glass slab is 3 by 2, correct. Then the apparent depth of the glass slab will be 2/3. Apparent depth will be 2/3. You're getting my point. If the refractive index of glass slab is 3 by 2, then apparent depth, what do you mean by apparent depth? From the top layer, top surface till where we see the object, that distance is nothing but apparent depth. How can we find apparent depth? Easily, just by looking at the refractive index. Apparent depth will be nothing but refractive index is 3 by 2, apparent depth will be 2 by 3. 2 by 3 of this complete height. 2 by 3 of this complete height. I'll give you one example. If the thickness, real depth is 9 centimeter, then apparent depth of the glass slab will be without refractive index. Okay, if the refractive index value, if you know, okay, if you know the value, then around you can write the answer. If the real depth is 9 centimeter, apparent depth will be 6 centimeter. How I got to know about that value? Very simple. I told you apparent depth of the glass slab is always 2/3 of the original height. 2/3, 2 by 3 into the original value. You will get an answer as 6 centimeter. Next, water. In the same way, water, but here we cannot take the thickness, correct. The depth we have to talk about the depth. Now, refractive index of glass slab is 4 by 3. Then apparent depth. Apparent depth will be 3 by 4. 3 by 4 into the original value. You will get the apparent depth value. That's it. So, this is how we are going to find the real depth and apparent depth. See, if the real depth is, you can aramse use the formula and get the answer. 9 centimeter, apparent depth will be 6 centimeter according to this formula. Okay, you can apply the same formula for all the cases. You will get the proper answer. Next, so now here this is the real depth and this much is apparent depth. Then what do we call this much? Okay, this height, this complete depth is real depth from the top layer till where we see the object, that is apparent depth. Then from the object till the surface, till the bottom surface of the medium, this depth is considered as shift. So this will tell us how much it has raised. See, the difference between apparent depth and the shift is very much important. Apparent depth is nothing but from the top layer till the object, what is the depth. But what is shift? Shift is nothing but from the bottom, where is the object kept, okay, from that point till where the object is raised, how much it is raised up. Whenever they are talking about how much it is raised, or if it is raised for 2 centimeter, all those things, they are definitely talking about shift. They are talking about shift. So shift is nothing but how much it has raised. Apparent depth is nothing but from the top layer of the surface till where we see the object. Shift and apparent depth, the differences are very much important. So till here we have learned the apparent depth, how to find apparent depth and what is the meaning of it. See, you need to understand the diagram, then only you can easily solve the questions. These kind of diagrams are asked in theory questions. So if you learn this one, aramse we can draw the diagrams there also. See, most of the time based on this concept, diagrams are least important, not that important, because most of the time these diagrams will not be asked in board exam. But for a safer side, we have to learn everything. We don't know what kind of questions they are going to ask. So for a safer side, we'll learn everything. Whatever the diagram they are going to ask in the board exam, you should be able to draw it. But whenever you are drawing the diagram, any diagram, use scale. Without scale and all, you are not going to get any marks. Okay, keep this in mind. If the diagram is not neat, you are not going to get any marks. Next, so now we'll talk about shift. This is the important concept, shift. Okay, so here shift, to find shift, it is very simple. S is equal to real depth minus apparent depth. Real depth minus apparent depth will get the shift value. They are very simple, right? But sometimes, you know what happens, the apparent depth will not be given. Okay, a value will not be given, real depth will be given, apparent depth will not be given. Then in that case we are going to use one more formula, that is nothing but S is equal to R bracket 1 minus 1 by mu. This is the one more formula. If real depth and apparent depth is given, very simple. This is real depth, this is apparent depth. If you subtract these two, we'll get this value, correct? So you can use this formula directly. If apparent depth is not given, then we have to go for this formula. And this formula, I know mu, most of the time mu will be given in terms of decimal. We have to convert into this one fraction to make the calculations easier. Those tricks and all we are going to learn in numericals video. That video will also be available in the description box. See, once you learn the concept, okay, from the textbook or from the video, don't assume you have learned everything. You just have learned only 50%. Remaining 50% is about solving all the numericals and all the theory questions. Then only you will get the complete knowledge, because here you know the concept but you don't know what kind of questions, how they will confuse you. That depends upon the questions. That is why I will always suggest solve each and every theory question as well as all the numericals. Then only we'll get the complete knowledge about a topic. Next, we'll talk about the factors which affect shift. See, refractive index is directly proportional to shift. If the refractive index, okay, you can write this one. What are the, if they are asking the state a factor which affect shift, you just have to write refractive index. That's it. They're asking just to state it. State means just naming it. So refractive index is one of the factor. If they are asking how refractive index and shift are related, if they are asking how refractive index and shift are related or in a different way, how refractive index is affecting a shift, all those things, answer remains same. Refractive index is directly proportional to shift. You should not use the short forms. You should always use the sentence form. Okay, then only you will get the marks, or else for this and all they will not give marks. You don't, for the reference, I just want to make sure you're learning all the symbols. That's why I'm using the symbols again and again. So whenever you get confused, just go back, rewind back and learn the concept easily. Next, refractive index is directly proportional to shift. What do you mean by that? That means if the refractive index increases, shift also increases. If the refractive index increases, shift also increases. That is the meaning of refractive index is directly proportional to shift. If they are asking how this is affecting, you can write this one or this one. Any one is fine. Next, thickness. Again, thickness, okay, is directly proportional. Thickness is directly proportional to shift. Okay, if the thickness increases, if the thickness of the glass slab increases, shift also increases. Next, finally, wavelength. Wavelength here, it is nothing but when it comes to light, it is, we are talking about colors. For different colors, different shift will be there. Don't assume for all the color shift will be same, because whenever we are talking about directly like this, okay, wavelength of some colors, we don't know, right? We don't know that color. Whenever we are not talking about any color, that means we are talking about sunlight or white light. Okay, so wavelength of white light is inversely proportional to shift. If the wavelength increases, shift decreases. That's it. So which color of light has maximum shift according to you? It is violet. Why? Because we are talking about maximum shift. To make the shift maximum, the wavelength has to be minimum, because these two are inversely proportional. So how wavelength is affecting shift? These two are inversely proportional, or else you can write it as if wavelength increases, shift decreases. That's it. Now this diagram, what is the meaning of real depth, apparent depth and shift? Many students will get confused whenever it comes to apparent depth and shift. You should not get confused. Apparent depth is from the surface till where you see the object, but shift is from the bottom of the surface till the object is raised. So this distance is shift. So all these things are very much important. Few more diagrams are left. After learning how to draw the diagram, we'll directly jump into learning the theory questions one by one. We'll solve all the theory questions. We are using the latest edition of the textbook, so we are going to learn many questions, as well as it is in order. Short, very short questions and long questions. After that, we are going to solve all the numericals. Watch everything and get the complete knowledge. Now we'll see few diagrams and we'll learn how to draw the diagram in the board exam if they are asking these kind of questions. Listen, very simple. Assume there is a stick inside a water. Okay, we will, whenever a person is seeing from this angle, they'll not see this depth of the stick, they'll see somewhere here. How should we draw the diagram? Very simple. Listen. Okay, see, from both top and bottom we'll get two rays. Okay, two rays. Because of the change in medium, they'll get refracted. From denser to rarer, they'll get refracted. Okay, they'll go away from the normal. They'll go away from the normal. So this is what we are going to see. Now, wherever these rays are refracted, if you extend that line, okay, here, right? So we see this stick is somewhere here. This stick is somewhere here. So if you extend those refracted rays, wherever the point is meeting, there we are going to see the stick. So this complete length stick will be made shorter whenever we are seeing from rarer medium to denser medium, and this is because of refraction. Very simple answer is this is because of refraction. Whatever the bending of light, okay, bending of stick, all those things, or if you are seen an object very big, okay, if it is small also, sometimes you will see it as a big object, that is also because of refraction. That is what we are going to learn here. Assume the object is in the rarer medium. The object is in the rarer medium and the person who is seeing, that is in the denser medium. How this is possible? A person diving or a fish is seeing something, a plant or something which is outside the pond. Okay, now this object is in the rarer medium, but the person who is seeing, the observer, is in the denser medium. But till now we have, whatever we have seen, the observer is always in the rarer medium, object was in the denser medium. This is a ulta case. Now see, whenever the object is somewhere here and a ray can pass through like this and a ray can pass like this, correct? A ray can pass like this. This is very much important. Students many times whenever they are drawing the ray diagram, they'll get confused whether this arrow mark should be towards the object or towards the observer. See, arrow marks are always should be always towards the observer. The arrow mark should come from the object. See, if the object is here, this is the object, right? The ray should be going from the object. Now this is the object, so assume this is a plant. Okay, the ray should come from the object, and wherever there is a change in this one medium, see, this is from rarer to denser medium, the rays will go towards the normal. The rays will go towards the normal. Okay, if there was no medium, this light would have passed in this direction, correct? This direction. Because of the refraction, it is going, see, this arrow mark is also wrong. It should go towards the observer. Assume the fish is in the pond or some person in the pond, they can see the rays like this. So wherever, if you extend this refracted ray, see, in both the cases we are just extending. This is the refracted ray, right? These two are the refracted rays, so we have to extend it. In the same way, you extend this one. So this will be the, this is the, if this is the observer, they'll see this much height of the plant, this much height of the plant, but the actual height is only this much. So this is from here to here, this is a real depth. The complete height, whatever the observer is seeing, is the apparent height, So what will be the conclusion? Very simple. If object is in denser medium, see, object is in denser medium, correct? This is the stick, this is in the water compared to air is denser medium, correct? If the object is in denser medium, then real depth is greater than apparent depth. Real depth is greater than apparent depth. This is the real depth. This is the apparent depth. Correct. So real depth is greater than the apparent depth. If object is in rarer medium, okay, rarer medium, then A will be greater than R. A is apparent depth, it will be greater than the real depth. See, this is the height of the plant, correct? If the observer sees from this point, this is how it is getting refracted. If you extend this refracted ray, wherever it is going to meet, okay, intersect at the same point, okay, and if you extend this point, wherever these two are going to meet, there that complete height from the top end till the surface is considered as apparent depth. So if the object is in denser medium, real depth is greater than the apparent depth. If the object is in rarer medium, apparent depth will be greater than the real depth. These two are the concepts. So this is very much important. Drawing the ray diagram, okay, all those things are very important. Now we learn our final concept, consequences of refraction of light, where we can see all these things in our daily life. Twinkling of stars. It's a very simple topic. See, stars will not twinkle. Okay, it appears to be twinkling. Why? Because we know stars are in space, correct? So there's a vacuum, completely vacuum. The light which is coming from the stars enters the earth's surface, and because of the this one medium, okay, a rarer medium, that is nothing but air. Okay, it was vacuum, then it enters the air, okay, air atmosphere. That's why they will get refracted. Once it get refracted, it will fall on our eyes, and again whenever there is a change in temperature, refractive index changes and the angle of refraction also changes. Because of that, we'll assume it as the stars are twinkling. So twinkling of stars is because of the refraction. And why we can easily see only sometimes the stars are twinkling? Because whenever there is a change in temperature, refractive index changes, and then because of that, star appears to be twinkling. Next, sunrise and sunset delay. Always whatever we see the sun, okay, which is raised up, okay, it is already raised up a few minutes back, but we are seeing it as a delay and we cannot predict it. Why? Because we don't know the actual position of the sun, correct? Now why it is happening? Again the same thing. Sun is in vacuum, okay, space. So and when the rays coming from the sun enters the earth's atmosphere, because of the refraction, okay, it slows down, correct? Because vacuum is considered as a rarer medium and the earth's atmosphere is considered as a denser medium. Rarer to denser, the light moves towards the normal, and the speed of light slows down. Because of that, so there will be always a delay in sunset and sunrise. During the sunrise, if you are seeing the position of sun is somewhere here, okay, and this is earth, the for this time sun position will not be here, it will be somewhere raised up, but we will not see that because of the refraction of light. Whenever there is a refraction, we know speed changes, correct? Next, coin kept in a glass vessel. Assume this is a glass vessel and this is where you have kept a coin. Okay, now if you are seeing from this angle, you are not able to see the coin. So if you pour some water, this coin would appear somewhere here, correct? Appears to be somewhere here. If you see from the same angle, aram you can see this is because of refraction. Then the print on the paper. Whenever there is a print on the paper, okay, a normal newspaper, if you keep a glass slab on it, this print on the paper will appears to be little raised up. That is because of the refraction of light. All these things are because of refraction of light. Then water tank appears to be shallow. That means the tank depth, okay, appears to be little small, okay, little small because of refraction of light. Shallow means decreased depth. Next, a person's leg in a pool. If you see any person's leg in a pool, it appears to be little short because of refraction of light. And sometimes the pool depth, okay, whenever you're seeing from the outside, okay, the pool depth appears to be very small, but whenever you go inside, you feel the real depth is more than the apparent depth. All these things are the examples of refraction of light. Now we have completed part C of the concept video. Now we are going to solve each and every theory question and as well as numericals. All those links will be available in the description box. Thank you.